are we now?
Okay, this is our gear division. We recently opened this up within 2 years. So everything we have here, we've developed from the ground up.
Right.
We had nothing. We had a couple of employees. After a local company, when we moved somewhere else, they came over here and we just started purchasing things that we felt we needed, and we're still, it's work in progress, but it's moving along.
It's funny how a work in progress to you guys means a fully functioning huge department.
So we have some equipment here that is not necessarily gear shop, but we just, again, looking for a home, getting it started up.
You got to tell me what these are.
These are Gleason cutters, spiral bevel cutters for a 26 generator. And again, special cut, sharpening is required.
This is the tool for cutting the gears.
This is the tool for cutting a gear.
Okay.
Correct.
Wow. So these are the ones with the actual cutting blades taken out.
Correct. See, yeah, they're adjustable. You have to move different things depending on your setup, your gear setups.
Do you guys manufacture the
We do
cutters
not.
yourself? No?
No. That is definitely a
that'd be
specialty item, like you would buy a
very-
milling cutter or something like that.
Very specialty.
Absolutely. Okay.
So this is where all the magic happens.
Yes, it is. Now this is a machine we're in the process of hooking up. It's a Genie. This will cut about basically a 48-inch diameter gear.
Wow.
Helical gear.
And is a lot of this kind of legacy equipment? Like, this is really interesting. Like,
Yeah, a lot of this equipment is from the 60s and 70s.
yeah.
They hold up fantastic. You almost can't kill them.
No. And I'm sure they are, not much has changed.
No.
You cut a gear the same way today you cut a gear back then.
So this is an external, but here we have a shaper that can cut an external or an internal.
Oh, wow.
And again, they're same.
I would love to do this.
Right. So I don't think we have a part in here right now. It's looking to see if I had, but he's just got it running. So he set it up. Depends on the setup. Well, again, internal, external, different sizes, different
So
depths.
your gear goes on here, and this thing
It's-
rotates while it cuts.
Correct.
Wow.
This one we recently purchased, so the guys we've cut a couple jobs on it. They still kind of mess around with it, making sure we're on size and we're able to, we're holding size and everything.
That's crazy. It's got that much force that's pushing it around.
Yeah, the gear guys here, they've been cutting gears for a very long time.
Now, did they come when you guys...
They came with the result of the other company leaving.
Right,
Yeah.
right.
So Wes is pretty progressive, and he says, you know a lot about gears, guys that can cut gears, and there's probably a void in this area now.
Yep.
So we decided to move forward with it.
And how is that going so far? Are you guys finding a lot of demand for this kind of stuff?
It's going good. It's a little slow off the tape, but we're picking up customers. We're picking up some of the customers are repeating now.
Oh, awesome.
So,
Perfect.
And we're also developing new websites, so we will spread the word about this business.
Right.
This is fairly new, and we want to make sure that a lot of machines are working properly, that before we get a big flow of work, we want to make sure everything works well.
Get all the bugs ironed out first.
Exactly.
This also helps a lot with our rebuilds too, because we rebuild a lot of gearboxes and reducers.
Right.
So now we don't have to go outside for gears. We control our lead time.
All in
quality.
house. You set your own pricing for yourself.
yeah, it helps for control.
Definitely,
Yeah.
definitely for quality in that regard.
Here's one of the big cutters on the machine. This is what a Gleason 26 generator is, and you can basically theoretically cut a 26 at miter, which would be a 26-26 ratio. However, you can cut larger depending on the pinion.
So where does the gear goes on this?
Yes.
And that spins while this...
Yes. And I think we have a small spiral over there cutting, if you guys want to take a look
Yeah,
at
I
it.
would love to.
Yeah, I don't have a large one in here for now, but we have I think a small one over here cutting.
So these are all gear cutting machines?
Yeah,
as
these
well?
are all gear cutting. These are all bevel gear cutting machines.
Bevel gear
Straight
cutting.
and spiral bevel, and then we have all our hob cutting machines over here. So basically this is a spiral bevel gear that we're cutting. And that's kind of how it's generated, you can see. Now
Wow.
this is something we run a setup on, a gear setup. And the guys come and set the machine, have to change the internal gearing of the machine. Once we cut one hand, we have to cut the other hand and develop it before we can run them out.
Right.
See, that's how we start. We start with this.
That's a blank.
That's the blank. Then we mount on this machine and cut the teeth.
And you turn that yourself, obviously.
Correct.
We can turn it, we can key it, and then we can finish grind it at the very end.
Now, do you... Sorry, I'm just trying to, this is, yeah, that's supposed to be, you almost don't know what's the workpiece and what's the cutter.
So this, if you looked at it, because you're looking this way, would be
Yeah.
a left-hand spiral gear.
Left-hand spiral gear.
Correct.
And that would go for hardening after?
Yes.
Right.
After pretty much all your machining is done, except for your grinding.
And what year would a machine like this be from? Is this 60s as well?
Oh yeah, I think so. Don, what years are these typically? 60s? 60s?
60s machines?
70s?
These machines?
Yeah.
Early 50s.
Early 50s.
Okay.
Wow. So you want to tell us a little bit about these machines, how we're making gears? How did you get into this?
I got into it because I lost my job at a place and they needed somebody to drive a forklift. I know how to do that.
And then somehow,
I was just good at math and they just saw it, and I started figuring out stuff for the other guys in the shop that didn't know how to do it. And actually, her uncle noticed that I was doing it, and they put me on the machines. And I started in 1981, and I'm still doing it.
wow, absolutely crazy. Now, how much has changed when it comes to, because we're looking at some of these machines, they are old tech. How much has changed between when you started to now in this field?
Well, the general, you generate a bevel out,
Right.
okay, with the cutter. That's changed very little. It's still almost identical to what it used to be.
Right.
Now, what has changed is you can program them with a CNC. It's just like a lathe. The lathe still turns apart, but you don't have to set anything. You don't have to have a
sit there
guy
yourself.
standing there running it. Right.
Now, these aren't CNC.
No.
These are not.
These were made from about 1935 to about 1951.
Wow.
And then they came out with something called a 106 that was replaced with a 641, and it just kept getting until they got to the Phoenix machines, which are CNC. And we plan on getting them one day.
Hey, the old stuff still works, right?
You got to start somewhere.
That's right.
And these are the best kind of job on.
Now,
if you want one set of something, this is what you want to do.
this is what you want to run it on.
Yeah.
How do you program this thing, or how do you set up? What size is it? Just you set it to the right spot, or like? Because I see it cutting.
This goes all. It's a whole. It's about 10 pages of actual math.
A lot of calculations.
Trigonometry to get this thing to get a setup. Okay. There's a swivel, a cradle, and then you start out with the cradle, which is Q, and then you go on and on and on. One little mistake, and her dad used to do it, and he would start over, and it took him 2 days.
Oh,
now I go in there, I get the ODs, the face angles, and number of teeth, and I can run a program in about 10 minutes.
Wow.
So that's come a long way since then. But there's a ratio gears in the back to work with the index. That's how you see the bevel.
Right.
Okay.
You just need to know what you're doing.
Sorry, that helps.
The whole thing is a circle with quadrants, and you got positive and negative quadrants.
Right.
The settings all come up to a positive quadrant. Your first quadrant, your second quadrant, and then if you fall into a negative quadrant, they don't run together.
I was explaining to him about what we do in the lapping operation, how you can bring in your
after we
bearing
get
and
this
change your
here,
bearing.
If you come over here,
Yeah, absolutely.
you get this. Whew. We come over here, and these machines, they aren't perfect. So you got to make change. Me as a gear cutter, that's why I come in. Again, a lot of math involved in it, and I start to change these things till you get them to where they can run real nice.
Wow. Now you're putting the paint on there so you can see where the interaction and
that's
contact
marking compound
happens.
to see where
Marking compound.
When I started this out, it was up here and up there, and it was at the top of the tooth and the flank of the tooth down here. The flank being the root.
Right.
So I had to make a tilt change. You just make all these changes to develop. They call it developing the bearing on it.
Now,
And,
do you need to do this to every one you guys run?
Don was an original.
every once in a while I luck out and I don't.
Right.
But most of them you got to change something.
Most of the time we got to do a bit, eh?
Again, the new Phoenix machines, they say you don't really have to do much at all to them. What they do is they probe them, the whole tooth. They send it back to Gleason, and Gleason sends them back the settings. Which the guys that run them really don't know anything about gears. They just they put on a cutter and the pieces.
Now, what kind of RPM are these things going at once they're installed, where they're at?
Again, it depends.
Depends. What about for ones like this? Maybe 3,000,
These here?
5,000?
No, about 1,800.
About 1,800?
Yeah. These go in little pumps.
Okay. Kind of like an impeller pump or something?
Yeah, it is.
That's super, super cool.
We do them like for cars, like for rear ends. The most best ones we did them for 1924 Packards.
Oh, cool.
And her dad figured out how to do them. They wanted to change the ratio of the gear, basically so they could go up over mountains.
Yeah, yeah, oh yeah.
So we did.
You made it happen.
And they loved them.
Oh, thank you very much, John. Really appreciate you. After meeting with Don, I'm here with Don. Nice to meet you. What are we doing here?
All right, this is a lapping right here. Basically eliminates all your break-in periods and stuff like that. Gives it a nicer finish on there. Quiets the gear set down.
Are these actually two gears right now that are spinning?
Yeah.
And they are interacting.
Right.
So you're putting the lapping compound on there to essentially wear them in a little bit.
Yeah, exactly.
How long would you run these for in this kind of operation?
I mean, depending on your finish on your gear set, maybe about a good 15, 20 minutes.
Oh, so not that long. You're not running them all night.
I mean, sometimes you could do some for, it depends on what kind of finish they want. Run them a little longer, maybe an hour, if they want them nice and quiet.
Right? No, it makes sense.
Some sets don't require that much. Also depending on the size of it too, obviously.
And how did you get into doing this? Because this is a very different, specialized trade. How did you get into the gear aspect here?
My dad's done it his whole life, so I kind of jumped in right after high school, looking for a job. I actually kind of liked it a lot, so
yeah,
been doing it ever since.
And this is kind of your specialty, is gear manufacturing.
Oh yeah. Specifically the spiral gears, which I initially started into. I also dabble in some of the other stuff too, like spur gears, helicals, worm gears, and stuff like that too. The basic ones, they run two parallel shafts together.
Right.
These ones you could kind of offset them, so you're running them at angles like that, Whereas your worm set, you'd be running on top of each other. That's kind of like the purpose behind it.
And do you guys do all different kinds here?
Yeah, all types of different. You got the thread mills and stuff, which do your worm and worm gears. You got the hobs, which do your helicals, your spur gears, stuff like that. And then this, all the spiral stuff, which you've already seen. Also do the straight bevels right there.
So these are all for spiral. That one's for straight bevel.
Yeah.
Right.
Yeah, this is all your bevel gears right over here. Spiral bevels, straight bevels. And all that stuff's over there. Going to be like your hobbing stuff, like spurs, helicals, and whatnot.
So what do we got here?
All right, so this would be your straight bevel tool sharpener.
Right.
The tools that cut your straight bevel gears, sharpen the tools on here.
Oh, wow.
Yeah.
Oh, so you mount the tool in there.
Well, this is the diamond right here. This is to dress the wheel. Over here, same concept though. You put the tool in here, come across it, bring it in, sharpen it up. And then these are like your angle settings and stuff for your tool. And then this one right here would be for your spirals. This is your spiral bevel gear cutter right here. Same
So
thing.
you guys can maintain these yourself in here?
Oh yeah.
Resharpen them?
Yeah, this is for the smaller. This is probably about the biggest cutter we could get on this one. That is just a larger version of this, pretty much.
And essentially horizontal, right? Oh no, it's the exact same.
Same thing, just bigger OD on it, so you can fit like the 12-inch cutters. You even get like up to 18-inch on there. So you just, one blade at a time, this index over, go to the next blade.
The one thing I have noticed here too is everything's super, super clean.
Yeah.
Is that just you guys?
Well, I mean, yeah, some stuff like that machine over there lapping, I mean, you can only keep it so clean, But yeah, we try to keep it as clean as possible.
Because especially when you're dealing with old machines like this, I have some old ones that, came with the shop, and they have, half an inch of grease on them.
Yeah, when we had got these were, some of these were pretty beat up, dirty. We cleaned them all up, painted them.
You guys put your own paint on them?
Yeah, we wanted
awesome.
to kind of color coordinate. We wanted like the hobbing or the cutting equipment to be gray, sharpening blue, and testers white. It's kind of like what we kind of went with there.
That's funny. I didn't notice, but definitely. What's this here?
And this is the hob sharpener right here.
Hob sharpener.
Yeah, so this one will, I don't know if I got a hob over here. There's the arbor. The hobs sit on here, come in here, and this wheel right here will grind a whole row of teeth right here.
And this is essentially your steady rest.
Yeah, well, this is your center right here.
Right, sorry, your live center, not steady rest.
Yeah, right. So yeah, this will sit between centers right here. This will lock in right here to hold it from moving or anything. And then just index around.
And this is much like everything else. This is all manual calculation.
This one has got a few more options where it'll index itself. But yeah, other than that, it is pretty basic.
Some very, very legacy knowledge
Oh
here.
yeah.
Wow.
Yeah, some of these machines that go all the way back from like the 40s and stuff like that. I think actually this machine right here is from like 1940 or something like that.
1940.
40 something, 42
Wow.
maybe.
What do we got over here?
Okay, so this is the thread mill right here.
Oh, I thought it was a lathe.
No, this is thread mill. This will cut like your worm and worm gears. This will cut the threads in the worm.
Wow.
Yeah.
So essentially, for those who don't know, worm gears are like giant threads, right? They're kind of like big screws.
The worm itself is a thread, and then you got a gear that rolls on it.
Right, because this one goes this way and this one, I'm doing that wrong.
Yeah, the worm will sit like this, it'll just spin.
Right.
And then the gear, it'll rotate the gear like without, just constant spinning.
And you can put multiple gears on that one worm as well, too, if you want
Yeah,
to, right?
you could branch them out. A lot of people do that to lower your ratio or higher your ratio.
Wow, and this is from the 40s, you were saying?
Yeah, I think it's got a date on here somewhere.
Wow.
This one's from 54, man.
54.
I think that one might be from the 40s.
Wow.
But yeah, you could also kick this head all the way up, horizontal, and also cut splines on it too.
Oh, wow.
Yeah, so that's the. But mainly, I mean, most people use them for the worms.
Yeah.
Because you can do it a lot more efficiently in these hoppers.
The nice thing about these ones too is that they're so big and heavy that it takes all the vibration and the backlash in.
Yeah, these ones are kind of hard to find because a lot of them they're more like these short bed ones over here.
Right.
But this one we found is actually really nice. You get super long shafts in here.
And are you guys pretty much always keeping an eye out for this kind of equipment coming up for sale?
Yeah, that's where experience really is beneficial. The guys know what machines are known, hold tighter tolerances, hold up better.
Right.
Yeah, that's something that's OJT. You don't get that anywhere else.
No, absolutely.
Yeah.
And what do we got back here? These are the Hob machines?
Yeah,
These
this is
smaller ones.
Smaller ones.
Yes.
Yeah, this is a really small one right here. It's a Barber Coleman 610, 6-inch OD it could fit, and then a 10-inch face width is what you could do on here. It's primarily smaller stuff on here. It runs in a square cycle too, so you can do some production stuff.
You got a workpiece.
That's your RPM gauge.
Yeah, this is for your cam. I think it speeds up your whole process a little bit.
Wow.
Yeah,
This is such
Yeah,
interesting machinery.
Right, this one's got a little bit more bells and whistles on it.
And this one is?
Yeah, I don't know. Some of these don't got dates on it. It might though.
But that's funny. I love these old nameplates.
Yeah, the old tags.
They're awesome.
Like this one right here, I believe it's 1941.
And this one's actually got the cutter still in it.
Yeah, this one we've already ran and stuff. That one we still need to hook up. But yeah, this one runs like a beauty. Cut a few things in here already.
And what's that one over there?
And these two are basically the same machines. So this one will do a 16-inch OD and a 36-inch face width. And that one will do the same thing, a 16-inch OD, but a 56-inch face width.
56-inch.
Yeah, huge.
And this is the actual cutter head, right?
Yeah, these are the hobs I was talking about.
Hobs.
That it'll come and sharpen a row of teeth on that sharpener over there. I'll just index over for each row.
And this can move back and forth?
This whole thing, so basically this cutter will spin around, the piece will be right here, and it'll slowly just generate the teeth in it, which you can see we had already cut in. This is our tooling.
This is a mandrel, right? Essentially, you just hold the part?
Yeah, right. We had got a part that had a very short little diameter to hold on, so we had to make something up that we could cut into and still hold on to the part,
And you missed your set screws.
Yeah.
You've done this a time or two, I see.
Yeah, that was the idea. But yeah, I mean, this machine right here, you can do spur gears, you can do helicals, you can do the gears that go with the worms on this also.
And I guess typically if you're doing one side of the gear, you're doing the other side.
Yeah.
Oh, that's cool. Super cool.
Yeah, man, that's it.
I guess you don't really have problems keeping busy here, do you?
We do not.
No.
We always have something to do, and if it's not, if it wasn't a customer job, there's enough machines in here that we're always replacing something or improving something. Tooling is a big one. You can make tooling for months,
Still not have enough.
Right.
I might steal one of these when I leave. If you're missing one tomorrow.
I know. The Cushmans are pretty cool, yeah.
much for showing us around today. Where can we find you online?
You can find us at mastermachinerepair.com. You can also shoot us an email at info@mastermachinerepair.com.
Fantastic. Thank you very much, guys. You have a
you.
great day.
Thank you
for coming.
Hope to come see you again soon.
And thank you. It was awesome. Thank you.
So there you have it, guys. Thank you very much for coming along with us, and thank you to the guys at Master Machine and Repair for having us out here today. Really, really fascinating place, guys. I know, yes, it's huge. It's easy to just say, oh, it's just a big shop, but I've never seen such a cool mix of giant machines, specialized machines, and especially some of the older stuff. Seeing some of that older tech still running by guys who, you know, spend all day keeping these things going and being productive is amazing. The other thing I really like to see were how many family connections are here. I think we counted 3 different sets of parent-child relationships here, not only all in the same trade, but under the same roof. And that's really amazing to see. Make sure you guys like and subscribe, but also let us know in the comments below what you liked about this and if you want to see more of these style of videos, because we are planning to go out, check out more shops, and I hope you guys will give us some recommendations of places to go. Thanks for watching, guys. You take care.